Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Color by Numbers by PageDo, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have cells connected by a pink Renban line form a set of consecutive digits in any order without repeats. So you could have something along the lines of like 6, 8, 7, and 5, and that would be valid because these 4 digits would be consecutive. And they form a consecutive set of digits without repeats. They form a set of consecutive digits without repeats. Because 5, 6, 7, 8 is consecutive, and that's an example of how Renban lines work. We also have numbers in a maximum gray cell with arrows pointing outwards. Some partially hidden are greater than all orthogonally adjacent non-maximum cells. I'm not sure what they're meaning by some partially hidden. Yeah, maybe they're talking about the arrows. But basically, this is saying that any cell in the maximum gray cells which have arrows pointing in some directions. Yeah, I think it's referencing the arrows are some of them are partially hidden. They must be greater than all cells that share an edge with it, which is what orthogonally adjacent cells are. And all cells that share an edge with it that are non-maximum cells. So for example, these two are maximum cells. Obviously, they both can't be greater than each other. So therefore, that's why we have that constraint, right? But they must be greater than all cells that share an edge with it that are not maximum cells themselves. So for example, we could have, say, 3 and this be 2 and 2. And this would be valid because 3 is greater than both 2 and 2 that it shares an edge with that is not maximum. And that's how maximum cells work. We have digits in cells joined by an x summed to 10, and digits in cells joined by a v summed to 5. So for example, if this were say, if this were say a 3, this would have to be 2, because these two digits must add up to 5, because there's a v between them. And this would have to be 7, because these two digits must add up to 10, because there's an x between them. And not all x's or v's are necessarily given. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, let's start with the v's in this puzzle. So the v's in this puzzle basically are all low digits, which are the digits 1 through 4. That means to add up to 10, these digits have to be high. And in addition, they form a Renban, so they must form a set of consecutive digits. And they all are next to an x. Well, since they're all next to an x, 5 cannot be one of them, because 5 plus another digit adding up to 10 would have to be next to a 5, but then we'd have a repeat in a row or a column for that case. So these must all be the digits 6 through 9 to form a Renban. That means the x that they're with has to be all low digits. The cells that are next to them with an x must be all low digits. So these are low, so these are 1 through 4 essentially. This digit is greater than that digit, and they add up to 10, so this must be the high, and this must be the low. These add up to 10, so we have one high and one low digit in this pair here. That means we have 4 lows guaranteed in row 7, which means the rest of the row has to be a high or 5 digit. In this upper left-hand box, we have 4 lows, so the rest must be high or 5. Let's see. We're not sure there. These must be, there must be a low digit here and a high digit here to add up to 10. So that means we have a guaranteed 4 low digits already in row 3, which means the rest in row 3 are high or 5. We have 4 low digits in row 5, which means the rest of the digits in row 5 are higher 5. Okay. 2, 3, 4. This digit is higher than that digit, so this must be the high digit of the pair adding up to 10. So this is low. These pair of digits obviously are not, so this high digit is not any of these digits, so it can't be here. So this actually could be there. This high digit has to be one of these 3. We're not sure which. This pair of digits, the low digit here, must add up to 5 with this low digit here, because we have a pair of digits here that add up to 5. So these two are the same digit, I should say. So then, what else do we have? Okay, let's mark the lows as different ones. We're going to mark one of them as orange as a pair to add up to 5, because we have 1, 4 or 2, 3 adding up to 5 as possible combinations. Well, if this were, say, 1, 4, that would eliminate 1 and 4 as possibilities here. So these must be a different set than this. So we'll make that one the orange. Therefore, this is different from that one, so those are both orange. These cannot be the blue, so they must both be orange. And where are these orange in column 3? They can't be here, they can't be here. And at least one of them has to be in this set here, which means both of them have to be in that set. So these are both orange. This cannot be the same as these cells here, so this is the blue set. Which means this can't be blue. This has to be the orange. One of the orange ones adding up to 10 there. This cannot be the blue set, so one of these is orange and high. So this is an orange pair here. This cannot be orange. This must be a blue pair here. And one of these sets are going to be low and low. So if this is low, this is high, this is low, and that's high. If this is high, that's low, this is high, and that's low. So we're guaranteed one of the blues here add up to 10. So this cannot be both blues. This has to be an orange pair. which means this is the other orange pair here. And both of these orange see that orange cell here. So this must be a low, which makes that a high here, correspondingly. Interesting. Yeah, maybe it's better not to do the highs and the lows then. Maybe it's actually better to focus on the XV pairs then. This is both orange here, which makes that a blue here, a blue here. Okay, so let's try to differentiate the blues then. Okay, so let's remove. These are guaranteed to be 6 through 9. We know that for certain. So we have 6 through 9 there. This is with a blue one. These are both blue as lows. This is, so, we'll make this one orange, and we'll make that, I don't know, yellow. And for the blues, I guess we'll make that blue, and we'll make this, I don't know, green. So this is a blue pair adding up to 10 there. This is obviously 6, 7, 8, 9. This is 1 through 4. This is 1 through 4. This is 6 through 9 here. We have 1 through 4 here. This is 6 through 9. This can't be orange because that's orange. So these have to be the yellow low. So these are both yellow. So this is blue and green as a pair. We have a low orange here, a low orange here. So this is the orange that goes with it. We have 1 through 4. These are all 1 through 4. So we have 1 through 4 there. Okay. This is the blue one. That's the green one. So both blue and green cannot be here. This is not orange, so this has to be yellow. Or you have yellow here, orange here, yellow. So this is both yellows, adding up to 10. This is one of the blues. We're not sure which. So this is blue or green here. These are both green. These are both blue. This is blue or green here. This cannot be the green high here because this is both green, so this must be both blue here. So this is both blue here, which means this can't be blue, it's green. This, again, has to be some combination of blue or green here. Let's see. So this has to be green high, which means this is blue high. So green low cannot be any of these. Green low has to be one of, okay, this can't be green low. So we have definitely green low here. Green high cannot be here. This is green low here as possibility or 5, and this is, so this has to be some combination of green or 5 also. So this is 5 or high. And remaining digits we're missing. We're missing a yellow high. Where is the yellow high in column 9? It must be here. So this has to be yellow high here. This could be any of them. So this is either low or high green or 5. Where is high green then in column 9? Can't be here because of high green in the box, so this has to be high green here. Which means we have 5 and a low green here. So this is definitely 5 here. What's the remaining digit here? It has to be a 5. Right? Because we have yellow going here as high. Yellow can't be high except for this cell here because this is a blue pair here. Orange pair here. This has to be high green because this can no longer be high green, and it can't be high green here because of the high green here. Therefore, this is a low over here. This can't be low yellow, so that's low orange, which makes this low yellow. And we have low orange here. This can't be low yellow, low orange, or low green because of low yellow and low orange in the row and low green in the box. So this is low blue. Okay. Remaining digits, we have low orange. Okay, this is orange here. This cannot be low orange. That's low yellow there. We don't know which ones of these are low orange. So low orange now in this upper right-hand box has to be here. So that's low orange, which means the remaining digits are 6, 7, 8, 9, and are high blue and high orange. Okay. Hmm. Okay, so for this cannot be a pair of greens because we have high green here. So this must be all blue, which means this cannot be a blue-blue pair. It's green-green as a pair, adding up to 10. We have remaining digits 5 and a high orange in row 7. This can't be 9 because 9 can never be smaller than another digit. This can't be 9 because 9 cannot be smaller than another digit. So the 9 in, well, it could be blue, I guess. High orange can never be 9 then. So this can't be 9 here, which means this can't be 1 correspondingly. So no 1 here, which means the low yellows cannot be 4, which means this can't be 6. So no 6 here. These are all blue. This cannot be yellow. Cannot be green. This has to be both oranges, which means this can't be the low orange. It has to be the high orange. This is low orange here, and this digit is less than 2 digits. So the low orange has to be, or the high orange has to be 6 or 7, which means the low orange is 3 or 4. So the low orange is 3 or 4. This is 6 or 7 because it's less than both of these digits, and they're 2 unique digits because they're on a Renban. So the low yellow is 1 or 2. The low orange is 3 or 4. So 6 or 7 with 8 or 9. The high yellow is 8 or 9. Okay. This cannot be both greens added together. This can't be both. Wait. That's a. Oh. Can't be both greens, can't be both blues, can't be both orange. This has to be both yellows here. So this is yellow and yellow. Yellow, low yellow cannot be here or here because of the low yellow in the column, the low yellow in the column, and it can't be here because of low yellow in the row, so this is low yellow here. Low yellow is one of those two. We have low orange. Cannot be here. So low orange is one of those two. The other blue cannot be here. So that means one of the blues has to be here. Right? This blue can't be there. So it has to be one of these two. What else are we looking for? high orange. Where is high orange in row 5? Can't be here because of the high orange in the boxes, so it's one of those two. We also know high orange is here. Also, this can't be 8, so it's 5 with 6 or 7 there. We have high orange here, high orange here. Where's high orange in column 3? It has to be one of these 3 digits. Okay. Um, Is that helpful? I'm not sure. This can't be 7. It's 8 or 9. Okay. This has to be 5, 6, 7, 8. So this digit has to be greater than 5, 6, 7, or 8, which makes this a high blue, which makes this low blue here, low blue here, low blue here. This low blue is guaranteed to be greater than 2 other digits. And this cannot be low yellow, cannot be low orange, so this has to be low green. Which it's less than that. Okay, this is not low. This has to be high. This is greater than low green, and both yellows are here, so then this also must be greater than low orange. Well, that means blue is greater than all, the low blue is greater than all the other low digits, which means the low blue has to be 4. So we have low blue here, low blue here. These are all 4. The high blues then have to be, I don't know what that is. High blues have to be 6 then to add up to those. This is only greater than 5, so this is 5 here. This is only greater than 5, so it's 5 there. This cannot be the orange, then this has to be the orange here. Where's the high orange in row 5 again? It has to be here. So that means this has to be 7 for the high orange, which is also there. And we have to have for the low orange, this can't be low orange. It has to be, oops. This is low yellow. And this can't be low yellow. So this can't be low yellow, which makes this low yellow here. So the low oranges are 3. And the low oranges must add up to 5 with the low yellows. So the low yellows have to be 2. That makes that 2. The high yellows then have to be 8. So these are 8. And that makes the high greens 9. And so we don't know what this is. This is not 2 or 3. It's 1 or 4. No 8 or 9 here. This is 6, 7 as a pair. No 2, 3, 4 here. No 2, 3, 4 here. This is 1, 5 as a pair. That forces this to be 9. We have 9, 1, 1, 9, 1 there. This is the low green. So this must be 1, which makes this 4, which makes that 1. So this is obviously not green left. We can start removing colors then, because we have a decent amount of information. Okay. This 6 has to be greater than another digit, which cannot be 2, 3, 4, and 5, so that leaves that as 1. Remaining digits in this lower left-hand box are 4, 8, and 9. 4 obviously can't be here, so 4 has to be there. This can't be 8 because of 8 in the row, so this is 9, which makes this 8. Remaining digits of column 1. We have 5, 6, and 8. This can't be 6 or 8 because of 6 or 8 in the row, so that's 5. This can't be 5 or 6 because of 5 or 6 in the row, so that's 8, which makes this a 6. That leaves the remaining digit in this left central box as a 9. Remaining digits in column 2, then, are 6 and 8. Okay. Remaining digits in column 3 have to be 5, 7, 9. 9 obviously can't be here because of 9 in the row. 5 can't be here because of 5 in the row. Remaining digits of row 5, let's just do that. It's a 9. Remaining digits of row 4 has to be 4 and 8. And this can't be 8 because of 8 in the column, so that's 4, which makes that 8. Remaining digits of column 5. We have 5, 6, and 7. Okay. And this can't be 5. So this digit must be greater than that digit. So it must be 7, which makes this a 6 here. So we have 7, 6 there. That makes that 5. 6 eliminates 6 here, so it's 7 and 6. 7 eliminates 7 here. So that's 9. This can't be 5 or 9. It's 7, which makes this not 7. That's 5. Remaining digits in column 6, we have 4, 5, and 6. So 5 and 6 cannot be here because of the 5, 6 in the box, so that's 4. That leaves us as 5, 6. This can't be 6 because of 6 in the row, so it's 5 and 6 there. Remaining digit in this lower central box is a 7. Remaining digit in row 3 is a 9. 6 eliminates 6 here, so it's 8 and 6. Remaining digit in row 1 is an 8. Remaining digit in row 2 is a 1. Remaining digits in row 9 have to be 1 and 9. Obviously, 9 cannot be smaller than this digit, so this is 1, that's 9. 1 eliminates 1 here, so it's 5 and 1, which leaves this digit as a 5 and this digit as a 7. And that's how you solve it. Yeah, it took me a while to get to figure out how I wanted to approach this, but yeah, it all worked out pretty well, I guess. I don't know if I would consider this very easy, though. I mean, if you've done a lot of XV problems, yeah, it could be very easy. But I don't know how intuitive this is for people who aren't as familiar with XV problems. And particularly coloring these, like, as separate things. And the execution isn't very easy either. So, I don't know. I think I'd probably classify this as easy. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.